solving an absolute value inequality problem type 3. I am making this video assuming that you've watched my other two videos for problem type 1 and problem type 2, and if you have not, you might want to go look at those ones before moving forward because this might be a little confusing without it. Alright, so Alex on this topic is actually going to just ask you for the number line answer. However, on the test, we're going to ask for your answer in interval notation and for the number line answer. So I'm going to be doing both just to get you ready for that. With absolute value inequalities, the first step is making sure that the absolute value is all by itself. So it should be a line, some stuff in the middle, another line, and that's it on one side. From there are two different things that can happen. So remember, if it's a less than sign, if the absolute value is less than something, that's where we sandwich the inequality. And if it was a greater than sign, we would split it into two. So just really quickly, if I had x greater than 2, this would split into x greater than 2 or x less than negative 2. If you had the absolute value of x is less than 2, it gets sandwiched between negative 2 and positive 2. So just the negative version of this guy. You're going to do the same thing when you get to having more stuff on the inside. If it's a less than sign, much like this, you're going to sandwich it into one inequality. You're going to start by making this guy negative, so negative 8, leave the inequalities in the same direction. And this is just the inside part of the absolute value. So you take the inside part and put it here. Here's where it gets weird, because we essentially have an inequality that's 3 pieces long. We have 1, 2, 3. With equalities and inequalities, we're really used to having one side and then another side, so a total of 2 sides. There are 3 sides here, but the rules are still the same. If you do something to one side, you'll do it to all sides. So to get rid of this 2 here, I have to add 2 in all 3 places, and that will cancel these 2's, so I can get the v all alone. So I have negative 6 is less than or equal to v is less than or equal to 10. If it's sandwiched, that means that you are filling in the middle portion. So I have negative 6, positive 10. I am putting closed circles because of the underlines. The underlines mean closed circles. If there is no underline, then you're doing open circles. Okay. And I did underlines here because the original had an underline. If the original did not have this underline, there would not be underlines here. And there is your number line answer. What's really nice about this is that this kind of screams to you what the interval notation answer should be. It starts at negative 6 and it goes to 10. So as a reminder, closed circles, those are associated with less than or equal to or greater than or equal to, which get brackets when we go to interval notation. Open circles are associated without the underline, and those get parentheses when we go to interval notation. But that's the answer for this one. So if we go to look at another one, x minus 4 is greater than 5. Here we have a greater than sign. Right? It has nothing to do with the underline. Sometimes people think it has to do with the underline. It has nothing to do with that. It is greater than. If you have a greater than, it splits into 2 inequalities. The first one, just act as if these lines aren't there at all. So x minus 4 is greater than 5. For the next one, you're going to leave this inside part alone, so x minus 4. Then flip the direction of this inequality. So if it pointed to the right to begin with, so we'll point to the left, and make this number negative. Now we're going to solve each of these individually, and there is an or between these. That will become important a little later for some other topics. So adding 4 to both sides, let me do that in red. Oops, having a hard time here. So plus 4, and that gives us x is greater than 9. Adding 4 in both places here, we have x is less than negative 1. So either x is greater than 9 or x is less than negative 1. Those are the values that we could plug into this inequality to get true statements. So, making a number line, -1, +9, If you have two inequalities, that's going to mean that you need to shade the tails. So everything less than -1, so open circle on the -1, everything less than it, and then open circle on the 9, everything greater than it. For your interval notation, you are going from -infinity up to -1, parenthesis, then there's a blank spot, and we pick up again with 9, and we go all the way to infinity. And that's the interval notation answer here. Right? Here's an interesting one, and you're actually not going to run into this on this particular topic, but I thought I'd bring it up anyway. You have an absolute value greater than a negative. And if you've watched the previous videos, you'll know that if there's a negative on one side, that weird things happen with absolute values. In particular, if you have x, the absolute value of x is less than a negative number, then there's going to be no solution, because no positive number, and absolute values are positive, no positive number is going to be less than a negative number. And if you have the absolute value of x is greater than, and you can always add underlines on this too, it's the same, greater than a negative number, all positive numbers are greater than all negative numbers. So this is going to have infinitely many solutions, and it's actually all real numbers. This is true even if there's more stuff on the inside. So even though there's a u plus 7 on here, if the absolute value is all by itself and the other side is negative, you're in a situation where you're looking at these guys here. I was about to write no solution, but this is a greater than sign. So positive numbers are greater than all negative numbers, which means this is an all real numbers scenario. Like I said, you're not going to run into this particular problem on this particular topic, but it's something I wanted to throw out there. Let's do one last one with something that you will run into. Here, we have an absolute value by itself. There's a greater than sign. So if it's greater than, you are pulling it into two different inequalities. The first one is as if those absolute value lines weren't there at all. The next one, you leave the stuff on the inside of the absolute value the same, flip this sign, make this negative. Okay. And then solve each of these, and there is an or in here. So subtracting 3 on both sides, we have y is greater than 4. Subtracting 3 on both sides over here, we have y is less than -10. So y is greater than 4 or y is less than -10. There's no underline on these inequalities, so they're going to get open circles. And you're shading the tails because you have two different inequalities. So here's the less than -10 part, and here's the greater than 4 part. For your interval notation, you start at -infinity and go up to -10, parenthesis, because you have an open circle, union 4 to infinity. Some people, when they're doing these problems, like to start it, let me give myself a little space here. When you start off, some people like to leave the one where you don't change anything, this guy over on the right-hand side, and then do the flipping and negative on this side. The reason that's nice is because it's in numerical order this way. So you have the less than part, which is here, and you have the greater than part that's here. So that's a choice that you could make. Either way, this is what you're looking at this topic, mostly this. This is what you're going to be doing in the topic. This is exam stuff. And I guess I'll see you in another video. You're doing great. Keep on doing what you're doing. Yeah, you're doing great. All right, bye.